Sorry. Okay, so we're going over measuring lengths and angles. Today's lecture is super brief. So the first thing we went over is undefined terms, and we saw the undefined term point, line, and plane. And these terms are undefinable in mathematics, but these are our starting points for defining other terms. The next thing we were able to do is actually go about defining different terms using those starting point terms, and so we were able to define segment, ray, angle, parallel lines, perpendicular lines, and circle. Now what we're going to go into is we're actually going to get into more math-based things, but very basic math-based things. And so the first thing we're going to look at is measuring segments. So the first postulate we have for measuring segments is the ruler postulate. And the ruler postulate states that the distance between any 2 points can be measured by finding the absolute value of the difference of the coordinates representing the points. So basically, we can measure the distance between 2 points by going about counting what the distance is. However, what this is saying is that we're always going to take the absolute value of those points. More specifically, what this means is that we can't have a negative distance. We always have to have a positive distance. So, for example, what we could do here is we could either do 19 minus 8 and then find the distance, or we can go about counting it. So we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Either way, we would find the distance, but that distance always has to be positive. That's basically what the ruler postulate states. And whenever we'd use the absolute value, is more specifically, let's say that this number line was in negative numbers. Well, let's say this was negative 8 and this was negative 19. We wouldn't have a negative 11 distance. Instead, we'd have 11. So you always have to use the positive value. Then we also have what is known as the segment addition postulate. The segment addition postulate basically states that if we wanted to find the entire distance of a segment, what we could do is we could add the parts of the segment together to find the entire distance. So here's an example. If L is between K and M, then KL plus LM would give us the entire distance of KM. So if I added KL plus LM, I could find the entire distance KM. So I could add those parts together to find the entire distance. So that's basically what the segment addition postulate looks like. Okay, so here is an example of where we would use the segment addition postulate, but in this one we're not given exact values like we were or like we're normally given. So what we want to do is see how we would solve this. So let me go ahead and share my other screen, and then we'll go about solving this problem together. Okay. Let's go. So we're going to try to solve this problem together. So what we're going to use is the angle addition postulate, which basically says that we can add two parts together to find the entire segment. But what we can also do is we can take the entire part and subtract one part to find the missing one. So this is asking what is the length of segment RS. So we're looking for the length of this segment right here, R and S. And we want to see what we've been given. Well, we've been given that the entire segment, R to T, the entire segment R to T is equal to 5x plus 1. So the entire segment R to T is equal to 5x plus 1. And then the segment ST, so S to T, is equal to 2x minus 3. So what you can see here is we've been given the entire segment RT, and we've been given part of that segment ST, and what we want to do is subtract those from each other to find the segment RS. Well, what the angle addition postulate tells us is that we can find the entire distance of RT by adding RS plus ST. And so now what we want to do is we want to go about putting in the missing pieces, so we know that RS is equal to 5x plus 1. Or sorry, we're looking for RS. My fault. We know that RT is equal to 5x plus 1. We're looking for RS. And we know that ST is equal to 2x minus 3. And so now what we want to do is we want to isolate RS to find what the missing length is. Okay. And so I'm going to go ahead and go. I'm going to move this equation over here. So 2x minus 3. So 5x minus 2x minus 3 equals RS. Now I'm going to go about and combine to like terms. So I get 5x plus 1 minus 2x minus 3 equals RS. 3x minus 2 equals RS. Give me 1 second, guys. I'll do it after my class. Okay, sorry about that. And so what we want to do is we want to combine like terms, and so this would actually not be minus 4, but it'd be plus 4. And so what we did here was we took 5x minus 2x, and then this minus sign gets distributed over here, so this becomes a positive 3, and so positive 1 plus positive 3 is positive 4. So therefore, we identified that RS is equal to 3x plus 4. that would be the length of our x that we would use, 3x plus 4. And so basically what we did is to find the segment RS, we took the entirety of the segment RT, subtracted by ST, and removed to find RS. So that is an example of how you use segmentation postulate if you aren't given the exact values. Oh, there's an echo. Let me see. Oh, that's fine. Okay, sorry about that.
No problem, it's better now.
Did it fix? Yes. Okay. So let me go back to sharing my other screen. Okay, so now we're going to get into bisecting a segment. So a segment bisector basically cuts a segment into two congruent halves. So in this example, we have TR, which is bisected by AB. And so AB would be our segment bisector. And so, okay. And so basically what segment bisectors do is they cut those line segments into two congruent halves. So that means that this new segment TP would be congruent to this segment PR. And so that is what a segment bisector does. Okay. We also have what is known as a midpoint, and this takes us into the midpoint theorem. A midpoint basically kind of acts the same as a segment bisector, but it is the point in the center of a segment that cuts that segment into two congruent halves. So for example, if P is the midpoint of this line segment TR, P is that midpoint, then because P is the midpoint, it is midpoint between T to P is the same distance from P to R. So basically it is in the middle of the segment, creating two congruent halves. Okay. Now we're going to get into measuring angles. And whenever we measure angles, we use what is known as a protractor. A protractor is a tool used to measure an angle in degrees. So you may have seen this before. It basically looks like a ruler, but it is in the shape of a half circle. And so that takes us into the protractor postulate, which basically says, given any angle, we can express it in a measure as a unique positive number from 0 to 180. And so I want to show you how to actually use a protractor. I'm sure you don't have a protractor at home, but it is fairly easy to use. Okay. So how we can use a protractor. Well, let's say we have this triangle right here, and we're trying to find all the measures of the angles of the triangle. Well, what you would do is you would take the protractor, and let's say I'll start with finding the measure of angle C. And so what you want to do is you want to put the center of this protractor where the center of that C is, right there. And then you want to align this line on the bottom exactly where that purple line is. So right there, it's a line. And then what you're going to do is you're going to look at starting from 0, see how many degrees it is. So it's not 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. And it looks like it is at 100 degrees. So that's where that line meets that angle. And so it'd be 100 degrees. I can check it here. Is it 100 degrees? And it says yes, angle, I got one angle correct. Now, same thing, if I wanted to find the measure of A, I need to match A directly where that center is. So right there. And then I need to make sure that my lines here at 0 meet these purple lines. And so 0 is going to meet the purple line right there. And then again, I want to start from 0 and find what it is. 0, 10, 20, 30, and it looks like it's in the middle between 30 and 40. So I will say it is 35. Okay, same thing for B. I want to put that at the center. And then make sure that this line meets where I need it to be. And then again, you always want to start at 0. And so this instance 0 is on the outside, but you still want to start from 0. So 0, 10, 20, 30, 40. And then right there is about 45. And so there you can see that I have found the measures of all my angles using a protractor. And so that's how you would use a protractor. Does anyone have any questions? Okay. Now we're going to look at different types of angles we can encounter. So there are 5 different types of angles that we often encounter, and here are 4. So we have an acute angle. An acute angle is any angle from 0 to 90 degrees. So it has to be greater than 0, but has to be less than 90 degrees. An obtuse angle is anything from 90 to 180 degrees. So it has to be anything greater than 90 degrees, but less than 180 degrees. A straight angle is equal to exactly 180 degrees. So whenever we have a straight angle, we know it's equal to exactly 180 degrees. And then whenever we have a right angle also equals to exactly 90 degrees. And so that is the different types of angles we might encounter. Another type of angle we might encounter is a reflex angle. And that basically is just an angle that is greater than 180, but is less than 360. Okay, so those are the 5 types of angles we might encounter. The next thing we're going to look at is an adjacent angle. What is an adjacent angle? Well, as you can see here, it is saying that JHK and GHK are adjacent angles. And so what does that mean? Well, what it means is that they share a common vertex and have a common ray. And so their common vertex would be H, and their common ray would be HK. And so they are adjacent because they are right next to each other, as well as they share that common vertex and a common ray. So adjacent angles are angles that are right next to each other that share a common vertex and a common ray. Okay, now we looked at the segment addition postulate, but we also have something which is called the angle addition postulate. And the angle addition postulate basically says that the measure of an angle created by 2 or more adjacent angles is equal to the sum of the measure of the individual angles. So basically what it means is in order to find the entire angle, JHG, what we can do is we can add one angle to its adjacent angle in order to find the entire angle of JHK. And so JHK is equal to 152, which is 22 plus 130. And so that's how you would use the angle addition postulate. Any questions about this? Questions, concerns? No? Okay, so now let's look at an example of this. Let's see here. Okay. Let me share my screen. Oh my goodness. Okay, so here's an example of where we want to use the angle addition postulate. Sorry, not that one, this one. Okay, and this one says in the diagram, DAB and DAC are adjacent angles. If DAC is equal to 25 degrees, so DAC would be this angle right here, is equal to 25 degrees, what is the measure of DAB? Well, in order to find the measure of DAB, what we want to identify is what the x is equal to. And so we know that DAC is equal to x minus 20, but we also know that DAC is equal to 25. And so those are one and the same. So DAC is obviously equal to DAC. So we could go like this, and we can find the missing value x by isolating x. That would give us 20. So x is equal to 45. And we can go ahead and check that by plugging it back in. So DAC was equal to x minus 20. And we also know DAC is equal to 25. So D25 equals x minus 20. We found out that x is 45. Is 45 minus 20, 25? It is in fact 25. And so now that we know that x is 45, we want to find DAB. And so that means we would plug in x where DAB is. And x is 45. So DAB is equal to 2x minus 10. How do I know that? Because it tells me right here. And I know that x is 45, so I can plug 45 in. So 2 times 45 is 90. 90 minus 10 is 80. So DAB is equal to 80 degrees. So that's how I would solve for the measure of angle DAB. But now I want to go ahead and use my angle addition postulate to solve for the last problem. And the last one says, what is the measure of BAC in degrees? Well, as I can see here, BAC is this angle. Oops, I didn't mean to do that. BAC is this angle right here. And that is the entirety of those two adjacent angles. So basically it would be this entire angle. And so if I wanted to find the measure of BAC, what I could do is use the angle addition postulate, which tells me that I can add my two adjacent angles together. So BAD plus DAC in order to find the entire angle of BAC. And I know that DAC is 25, and I just found out, oops, DAC is 25. And then BAD or DAB, which I just identified was 80. And so I could add those together, and that would give me equals 105. So DAC is also equal to 105. So that's how I would use my angle addition postulate to find the measure of the entire angle BAC. Any questions here? Questions, concerns? Okay. Let me go back to sharing my other screen. Okay. Okay. And now we're going to look at one more thing. So very much like we had a segment bisector, which cut a segment into two congruent halves, what we also have is an angle bisector. And an angle bisector also bisects an angle into two congruent angles. So say I had this entire angle, ABC, which was equal to 80 degrees. Well, if I added an angle bisector, that angle bisector would cut that angle into two congruent halves. So 80 divided by 2 is 40, so this half would be 40 and this half would be 40. I could also bisect this entire angle, JPL, into two congruent halves using this angle bisector, BP. And I could also bisect this angle and MP into two congruent halves by using this angle bisector. So an angle bisector basically cuts an angle into two congruent halves. Any questions about that? Okay, so here are all the terms we went over today. We learned what a bisector is. Congruent segments are basically segments that have the same length. Learned what a midpoint is. It is the middle point of a line segment. A protractor, we learned how to use it. Acute angles, adjacent angles, congruent angles, obtuse angles, right angles, and straight angles. These are all terms we went over today. Does anyone have any questions about any of these terms? Okay. So we are done for today. If you didn't submit to the check-in, please do so that I can mark you present for attendance. But other than that, I will see you guys tomorrow. Bye, guys.